My name is Luba Konnova, and I'm a QA manager at Exactpro.
Раз. Hello everyone, my name is Artem Berko. I am a QA analyst at Exactpro.
We are very happy to be here today, and we're also happy to see all of you. Thank you for coming again. And today we will speak about complex post-trade systems, requirements, traceability, and illusion of control.
So, as that has been said by previous speakers, Exactpro provides software testing services for mission-critical technology infrastructure that underpin the financial markets, depositories, exchanges, clearing houses, etc., all over the world. Testing activities around post-trading platforms require a high level of expertise from QA specialists, as are they associated with a number of challenges. These challenges are caused by certain characteristics expected from the present-day trading platforms. So, look at this picture. We can see they have a very low latency, within 100 microseconds, have a significant throughput and capacity measured within 100 million transactions. So, and they should be resilient, have the ability to recover after outage, and have no single point of failure. So, it takes special tools and special skills to test such systems. But even these super challenges in high-frequency trading systems pale in comparison to those presented by the post-trade infrastructures. The main challenge faced by QA specialists when dealing with testing post-trade systems is the extremely complexity. So, first, this complexity is caused by the structure of post-trade system. There is a multitude of components and upstream and downstream system dependencies. The participant structure is very complex. It usually works with a variety of asset classes and has a multiple of endpoints accessed via diverse APIs and protocols. Okay. Second, the complexity presents itself through the processes that are part of the post-trade system daily life cycle. So what does it mean? Every day a clearing system runs some routine processes, including trade upload, collateral uploads, smart computations, reporting, etc. They are repeated every day in predefined order and in predefined times. Needless to say, that these processes are dependent on each other.
No? Berk?
Thus, to test a clearing system properly would mean to test all of these repeatedly happening processes, and moreover to test them with all multitude of parameters caused by the platform structures, participants, connections, asset classes, calculations, APIs, protocols, etc. Next. And the testing processes becomes more challenging if a platform is being replaced, and the testers have to simulate flows involving upstream and downstream systems. And now that we've outlined the challenges associated with the post-trace systems, let's discuss what cognitive patterns can affect their testing.
So do you recognize this magic glove? Yes, I hope yes. So these are the 6 cognitive biases in our perceptions that are capable of killing every software testing project. Some research is available that they impact the software development life cycle. Predictably, it confirms our pre-existing belief that the main bias affecting software testing is confirmation bias. Please raise your hands if you understand what is confirmation bias. Okay, I will speak about it in detail. For example, if I strongly believe that my clipboard is blue, from all the information around me, I will pick the data that will prove that it's blue. Although someone will tell me it's black, I will ignore it. So in scientific terminology, confirmation bias is a person's tendency to look for facts that strengthen pre-existing beliefs rather than diffuse them. Meta-research across peer-reviewed publications hasn't identified any articles describing the impact of other biases on software testing. So it would be interesting to collect the other 5. Congruence bias. Congruence bias is somewhat similar to confirmation bias. It occurs due to over-reliance on directly testing the given hypothesis, as well as neglecting the indirect testing. Once you have a testing approach, you tend to stick to it. That is why we see frequent requests to automate user stories or manual verification steps instead of building a comprehensive end-to-end library. Congruence bias decreases the adoption of such advanced software testing techniques as passive testing and post-transactional verification, leaving a huge space of unexplored conditions untouched by the test execution. From direct testing, let's move into how we interpret things. We tend to reason about objects or processes around us by analogy to humans. It's called anthropocentric bias. It defines our reality. So here it is a vivid example. I will need a hand to show it. In the United States military was testing a robot, and it was shaped like a stick insect, like this. And it would go, its aim was to blow up mines. And it would go on a minefield, and every time it stepped on a mine, one of the legs would blow up. And it would continue on the remaining legs until all the mines are just disarmed. But when only a single leg was left, a colonel who was in charge of this testing exercise ended up by calling it off, saying it was too inhumane to see this damaged robot drag itself in the minefield. For more stories like this, I would like to recommend the wonderful TED Talk by Kate Darling about compassion and plea dinosaurs. Yes, is it really a problem? Do we really expect to threat our post-trade systems with empathy similar to a robot toy? I hope not. But people do tend to humanize the surroundings of the system under test, and we frequently think that the most important interactions are the ones that can be touched by humans and seen by humans. Therefore, the test cases that are produced when we follow this perception are mostly focusing on creating Excel files and screenshots, etc. But this leads us sometimes to a situation when we have screenshots of file folders as test evidence. Instead, complex post-trade systems usually functions from multiple endpoints, which are frequently inaccessible by humans in an efficient way. Therefore, the best way to test it is with a ruthless and cold-hearted test automation tool, such as an Exactpro tool, ClearTH.
So, as you can see, our solution combines exhaustive testing of the required functionalities and deeper automatically generated checks based on the data dynamically extracted from the system itself. ClearTH tool is now extended with a plugin, so it's providing enhancement of existing software testing capabilities. Woodpecker. Like ClearTH, the extension is aimed at the testing post-trade systems and integrates with its automated scenarios. As its improvement, it combines functional and non-functional approaches, allowing to flood the systems under test with an algorithmically generated data flow, thus providing perfect coverage of the possible testing scenarios without any human interference. As a result, this approach prevents from biases, impact, and explores the system under test from different angles, being able to uncover defects in the confluence of functional and non-functional testing areas. ClearTH end-to-end scenarios is not simple. Their complexity reflects the sophistication of the system under test. Yet, we frequently encounter the desire to get back to clear and allegedly transparent ways of testing that links a simple user stories to simple actions. Here is another gem to us to look at Parkinsons Law of triviality. So, such known as a bike shed. Anybody hear about this law? Okay, is a tendency to give disproportionate weight to trivial issues, the soul of inefficient testing. So, Parkinson provides some example of a committee whose job was to approve the plans for the nuclear power plant. What they did, they spent the majority of their time to discuss, time on discussion about relatively minor but easy to grasp issues. So, such as what materials to use for the staff bike shed, while neglecting the proposed design of the part of the plan itself, which is far more difficult and far more important and complex task. So, we should not focus on easy to grasp issues and UI iterations. Having said so, there is one type of interface, of user interface, that truly deserves all attention it can get. Failure indication. So, why? The world's nuclear power plant partial meltdown in history and the most well-documented technology disasters have a common component. So any problem can turn into a catastrophe when monitoring and alerting system is not okay. The outages in complex technology infrastructures are like death. So They are inevitable. It is not the question if, it is the question of when. The summary course states the only way to live an honorable life is to constantly think about death. So the same is true when we operate in large-scale systems, constantly thinking. Oh, yeah, conscious microphone.
So, can we switch the microphone, please? It seems it's out. It's low.
Oh.
It's
Thanks. So, constantly thinking about the outage is only way to focus on proper monitoring systems. So, Clear TH contains capabilities to run tons of negative scenarios and automate resilience testing. We also have procedures for doing it in the cloud using Kubernetes. But a human is required to really look at the indicators and study what the outage will look like.
It's mine.
No.
Okay.
Thanks. So, humans hate risk and ambiguity. Zero risk bias is a tendency to prefer the complete elimination of a risk, even when alternative options produce a greater reduction in risk. So, on many projects, we've observed that the sole focus goes into implementing new user stories, as if there is no time, no past, and no future. It's true that the problems are more likely happen in the new functionality, but in large-scale, complex platforms, the true danger lies in inadequate regression. People create test cases based solely on some news stories in the test management system. 1 or 2 test cases per each requirement. On some of our projects, we've heard claims that this allows to obtain compliance requirement traceability.
So, this is our milestone, illusion of control. The tendency of people to overestimate their ability to control events that gives them a false sense of security. Instead of trying to comprehend the universe, we are focusing on a small, manageable subset. Completed requirements traceability matrix makes stakeholders happy. The sense of control makes people happy. Scientists believe that biases exist as protective mechanisms regulating our well-being. So experiencing biases actually makes us happier. Research also highlights that people with depression are less subjected to illusion of control. But software testing is not about happiness. Quite the opposite. It's all about broken things and misplaced expectations. Software testing is the art of unhappiness. So here I was going to cry, but a bit later. Okay. Illusion of control makes us happy, but inefficient. An experiment was conducted on a number of traders and showed that people with a high level of illusion of control perform less effectively than traders with low to moderate level of illusion of control. We believe that requirements traceability matrix focusing on a small manageable subset of the system is just an illusion. Instead, Exactpro is building a framework that will allow us storing the output of hundreds and thousands of test nodes in a single test database. We collect not just pass-fail outcomes of every test execution, but also network traffic, logs, system configuration, defects, etc. The raw data is converted into sets of raw files and is structured in such a way that can be accessed by distributed queries. So instead of running a single test case per requirement, it allows to perform, in order to perform compliance checks, we need to run our analytical queries against the whole test database.
So, to learn more about application of the proposed approach, we would like to ask you to join our annual conference in London, Extend, Software Testing and Trading Technology Trends. We are always looking for more ideas in this area, and we'll appreciate your contribution into the conference agenda. Extend headquarters in this year is the iconic Leiden Hall building. So, looking forward to seeing you there. Now we can get some questions.
Thank you for your attention. Oh.
Yeah, thank you for this amazing presentation. ClearTH is a very smart tool. It can simulate a lot of external systems where your testing system is should connect to. But how do you prove that it will work with real systems?
Yes, thank you for the question. It's a very good question. Indeed, when we simulate clients' connection, first we need to learn about clients. So how many connections, from which API they're planning to connect, the speed of information that should be sent, in what way, whether the client plans to send some rubbish over API or whatever. So first we need to work with clients and understand the requirements from technical point of view, KPIs and connections. And when we do testing, we tend to connect just in the same way as clients connect. This is not also used for functional testing, but as you saw the Woodpecker plugin, for example, while we are testing, for example, one portion of the test, Woodpecker would simulate that other clients are also connected and are trading or sending trades or whatever is done, whatever activity is done in the system. So we're using several simultaneous connections which simulate real ones with a real speed, sometimes higher than usual, but to create the background noise just like in a live application. Huh?
Take some production parameters.
Yes, and naturally we need to collect production parameters to be able to plan such testing activities. Yeah?
Okay, thank you.
Thanks a lot.
Thanks.